Hello and welcome to our lesson 7.7 video notes for scale drawings. Today we're going to be looking at interpreting scale models and using scale factors to solve problems. And you'll notice the format for these notes is a little bit different. I'm just going to write directly on the notes page that you should have. There's a couple of vocab terms I want you to make sure you have, and that's scale model, which is also called a scale drawing. And there's one definition for that. And then the scale is another definition we'll talk about. And here's what we should have for those terms. A scale model or scale drawing is an object or drawing with lengths proportional to the object it represents, and the scale is the ratio of the length of the model or drawing to the length of the object being modeled or drawn. So we're going to always represent that ratio with our model or drawing measurement first, followed by the actual real life measurement. And so usually it'll be like inches to miles or centimeters to feet or something like that. Okay? Alright, so here's our first example. In our first example, we are talking about the situation where we have the distance between Boston and Chicago on a map is 9 inches. If the scale of the map is 1 inch to every 95 miles, what is the actual distance from Boston to Chicago? And these are really easy to solve as long as we set up a proportion. So I'm going to start with taking that scale and writing it as a ratio in fraction form, 1 inch over 95 miles. You don't need to include units of measure. And that should equal the ratio of whatever measurement it is that we're using and trying to find. They give us the distance between Boston and Chicago on a map, which is in inches. So it's going to go in the same place in our ratio as the 1 did in its ratio. So we're going to put our 9 inches on the top. We are looking for the actual distance from Boston to Chicago, so we can call that x. And that'll be measured in miles. And so now all we have to do is cross multiply. 1x, or x, is equal to the product of 95 and 9, which is 855 miles. Okay? Alright, so why don't you try and use that same example to try and do number 2 on your own, and then pause the video so you give yourself enough time to do that. And then when you're ready, click play and check your answer. Alright, this is what we should get. Again, we have our 1 inch over 90 miles ratio, and that should equal 8 inches over x miles for the actual distance. And so when we cross multiply, x times 1 is just x, and 90 times 8 is 720 miles from Cheyenne to Tulsa. Alright, let's take a look at our next example. Example 3, we have a miniature replica of a fighter jet that's 4 inches long. The actual length of the jet is 12.8 yards. What is the scale of the model? And so this problem is asking us to actually write what that ratio is in simplified form. Remember, the ratio for scale model always compares the length of the model to the actual length. And so we're going to represent the length of the model as 4 inches to the actual length of that same jet of 12.8, and we're going to write that in terms of 1 inch to how many actual yards we get. Okay, so in order to make this a 1 over something fraction, we need to divide both of these by 4. So I'm going to take 12.8 and divide it by 4, and we get 3.2. That means our scale is 1 inch to 3.2. I wrote the wrong thing. 3.2 yards. And that's how we should write our scale. We don't want to write it as a decimal, less than 1, as a percentage or anything like that. We want to write it like this. Okay, that takes us to the back of the notes. Another similar problem, a miniature replica of a fire engine is 9 inches long. The actual length of the fire engine is 13.5 yards. So how many times as long as the model is the actual fire engine? So let's actually write that ratio out. We have 9 inches to 13.5 yards. Okay, and so again, we want to compare that as down to 1 inch, so we're going to divide 9 inches by 9. We need to divide 13.5 by 9 also. 13.5 divided by 9 is 1.5 yards. Now this ratio makes it look like the fire engine is 1.5 times as long as the model, but that's not accurate. These are in inches, these are in yards. We need to actually convert that number of yards into inches so we can make an accurate comparison. Okay, so 1.5 yards, remember a yard is 3 feet, so I'm first going to convert it to feet, and then I'll convert that to inches. So I take 1.5 times 3, and that's 4.5 feet. So 1 inch of the model represents 4.5 feet. But then I'm going to take that number of feet and multiply it by 12 to get the number of inches, which is 54 inches. So we're going to use this ratio. The actual fire engine is 54 times the length of the model. So make sure when you're answering the question that way that you are in fact using the same units of measure. Okay, let's take a look at example 5. Gerard is making a scale model of his classroom on an 11 by 17 inch sheet of paper. If the classroom is 20 feet by 32 feet, choose an appropriate scale for the drawing and determine the drawing's dimensions. So let's start by trying to figure out what the amount of feet per inches could be if I take 20 feet and divide by the 11 inches of my sheet of paper. Okay, and I want to take 20 and 11 because they're the narrower of the two dimensions. 17 is the longer one, 32 is the longer one. So if I take 20 and divide by 11, I get about 1.8 feet per inch. And then if I take the 32 and divide by the 17, I get about 1.9 feet per inch. And so I could do a 1 inch to 2 feet ratio. Every 1 inch represents 2 feet, and that would cover that. And I'm choosing 1 to 2 because these are each just a little bit less than 2 feet. And so if I round up to 2 feet, I should have enough room on my piece of paper. So we're going to take our dimensions. We're going to take this ratio, 1 inch to 2 feet, and develop our dimensions of our scale drawing by putting a length of over 32 feet. And let me go back and do the inches one, or the width one. 1 inch over 2 feet equal to a width over 20 feet. Okay, we cross multiply each of these. Okay, we get 2 times our width equals 20. So our width is actually 10 feet, or sorry, 10 inches is our unit of measure we get. And then same thing here, 2 times our length is 32, and divide both of those by 2. Our length is half of 32, or 16 inches. Okay, so our dimensions that we end up with are 10 by 16, which fits on the 11 by 17 inch piece of paper. So we're using a 1 inch to 2 feet ratio and getting 10 inches by 16 inches. Alright, let's try a final example here. Elena is an architect making a scale model of a house in a 15 by 26 inch display. If the house is 84 feet by 144 feet, what would be the dimensions of the model using a scale of 1 inch to 6 feet? Alright, so they give us the scale this time. 1 inch to 6 feet. We're going to find our dimensions by using the 84 and the 144. Okay, first let's take the 84. This is our width measurement. And so we're going to cross multiply again. 6W equals 1 times 84, or 84. So we divide by 6. And we get 14 inches. Alright, we're going to do the same thing for our length of 144. Use our 1 inch over 6 feet ratio, set our unknown length in inches over our known length of 144 feet. 6L would be equal to 144. Divide by 6. And our length of our scale model is 24 inches. So the dimensions of the model are 14 inches by 24 inches. And that'll fit in the 15 by 26 inch display. Alright, that wraps up our notes over scale drawings. Again, it's just making sure that you get the scale set up correctly and getting the correct units of measure placed in the right place, and you should do just fine. We will work on this assignment in class. Otherwise, enjoy the rest of your evening.